Scientifically, what are the things that we think of as being the most revolutionary aspects of Darwin's theory of evolution? I would say that there are two aspects. One is obviously evolution through natural selection. The idea that speciation occurs because some individuals within a population have advantages randomly distributed that other members of that population do not possess. And in times of scarcity, for example, those particular attributes allow them to thrive where others die and fail to reproduce. The random variations that these individuals possess allow them to reproduce and pass on those traits to the generations that follow. Natural selection as being the principal mechanism of speciation. The other radical aspect I think that we can think about is the notion of the branching tree, of the principle of divergence, the idea that through natural selection, at some point, two populations start separating from each other. And they might run parallel for a while, but the longer time goes on, the more they're separated. This was certainly the things that Darwin thought were revolutionary about his ideas. But we can only see how revolutionary they were when we start looking at the older models of evolution that predated Darwin. But let's start with these renegade evolutionary models, or transmutation as it was called at the time. And where better to go to than the ideas of Erasmus Darwin? We might think of him as Darwin before Darwin. A man, we might think of him as Darwin before Darwin. Darwin's grandfather was also a member of the famous Lunar Society, a body of men from Birmingham, radicals, scientists like Joseph Priestley, who once a month would meet in rooms like these to discuss the state of the world and to explore new ideas. Now, it was called the Lunar Society because the meetings always took place at the full moon. The reason for this was, in those days, there wasn't any street lighting, and it was pretty difficult to get home. And you know, these guys like to drink or 2 or 5 or 10, and they could use the light of the moon to stagger home after holding their extraordinary discussions. Erasmus himself was a deist. He was almost anti-religious. He was almost bordering upon the atheistic. He also had an essential belief in man's potential for progress. And during the 1790s, he expounded an early version of transmutation theory, but most extraordinary of all, he did so in verse. Organic life beneath the shoreless waves was born and raised in ocean's pearly caves. First forms minute unseen by spheric glass move on the mud or pierce the watery mass. These, as successive generations bloom, new powers acquire and larger limbs assume, whence countless groups of vegetation spring and breathing realms of fin and feet and wing. What he's putting forward here is a whole range of ideas. As we will see, there are similarities between Erasmus's vision of transmutation and that of Lamarck, a figure who was eminently more important in terms of putting evolutionary ideas in the early 19th century. Jean-Baptiste Pierre-Antoine de Monet, Chevalier de Lamarck. His name denotes his aristocratic origins. Starting out his adult life as a soldier, he turned to botany, and as a botanist he was able to obtain a position as keeper of the herbarium in the Jardin du Roi, the King's Garden, one of the principal scientific institutes of the second half of the 18th century, before the French Revolution. By 1793, and after the revolution he becomes professor of invertebrate zoology at the Natural History Museum. At this point we know that he still believes in the immutability of species, but it's this study that allows him to develop his theory of transmutation, which he begins to propound by the early 19th century and becomes known as the main man of evolutionary thinking before Darwin. Now, Lamarck's theory starts off in a very similar place to Erasmus Darwin, the belief that all life is the product of spontaneous generation. Now, at first, this act of spontaneous generation creates a simple organism, maybe a single cell organism. But each organism that is created possesses within it a tendency to become more complex. It's almost like a form of life force that impels the organism upwards. And Lamarck believes that critical to shaping this process is the environment. And the other point is that life is continually spontaneously generated. It is going on all the time. It could be going on in the corner of your room. You wouldn't be able to see it because of the microscopic nature of that life. Now we can understand his theory better if we look at this graph. Mapped out here is a scale of time, the beginning of creation, running right the way through to the present day. And we can imagine these green dots as being hypothetical points of spontaneous generation. Now this is the scale of organisation of each organism, starting out as less complex at this point in time, becoming more and more complex as time moves on. So let us imagine this, the creation of a simple form of life. This has been taking place on this scale since time immemorial, right back there, right back there, right back there. But imagine this act of spontaneous generation going on close to the present. At the present day, where these yellow dots are, it has become a barnacle. Imagine too this ancestral fish created way back in time. By the present day, it has become the modern day hippopotamus. Going way back, way back, way back, way back. Way, way back. Imagine that single cell organism being created almost at the dawn of time. Over time, it has become more and more complex. Ultimately, somewhere up there, it transforms into an ape that transforms into a human being, the most complex of all organisms. And it's taken that long to create. And of course, if we go off into the future and follow this line, somewhere up there, human beings will, given the right environment, emerge from this process. Now, because of the nature of the environment, Lamarck believed in what we can think of as a branching chain of being. And this is a quote from Bowler that discusses how this particular chain of being worked. It's easy when you look at this to think of the kind of trees that Darwin produced, but that would be a mistake. As we watch this unfold, if we start off with a simple life form like the worms, impelling upwards, becoming more complex, at some point when they're transformed into insects or crustaceans, given the particular environment, their development will stop and they'll stay there. But they might go on, becoming more and more complex, branching off to become barnacles and mollusks, fish and reptiles. Dead end there at the moment with the birds. Branching further to amphibious mammals. Whales, dead end. Hoofed mammals, dead end. Mammals. Keep on going until eventually you get to Homo sapiens. It is sometimes really hard to get one's head around the fact that in the Lamarckian model, one species is continually shading into another species as it becomes more and more complex. As the great man himself said, thus among living bodies, nature, as I've already said, definitely contains nothing but individuals which succeed one another by reproduction and spring from one another, but the species among them have only a relative constancy and invariable temporarily. To which someone might reply, for example myself, so Jean-Baptiste Pierre-Antoine de Monet, Chevalier de Lamarck, how can there be such a thing as a species? After all, they're a temporary stage in an organism's climb up the scale of progress. To which Lamarck replied that they were, in effect, something of a convenience to allow us to study nature. Nevertheless, to facilitate the study and knowledge of so many different bodies, it is useful to give the name of species to any collection of like individuals, perpetuated by reproduction without change, etc., etc. Now, underneath this all were laws. And these were the laws. In every animal which has not passed the limit of its development, remember those branches that ended in a dead end? Those were organisms that had reached an environment that had not allowed them to strive further, and they'd resulted in a dead end, whereas others had shaded off into a branch where they could become more complex because of the environment they were existing in. So here he's putting forward the idea that in one generation a particular organ might develop in such a way that it becomes stronger or bigger, more prominent. And this through the striving process within a particular environment. And in the Lamarckian model, this would be passed on, the acquired characteristic would be passed on to the next generation. And this emerged into his second law, where he elaborated in detail the idea of acquired characteristics being passed down to offspring. It is, of course, in Lamarck's giraffe that we are able to understand his ideas, albeit that he only mentioned the giraffe very briefly. But it seems that this is something that we can really get our head around to understand Lamarckism. Now, in his model, the giraffe would have started out short-necked, rather like the giraffe on the left. The highest leaves are the tastiest leaves, and the giraffe is continually stretching its neck to reach the higher leaves, stretching. And as it stretches, its neck gets infinitesimally longer. And it's that is passed on down to the next generation and the next generation until the neck elongates until you have the modern day giraffe. The ideas put forward by Lamarck were pretty radical, and they were really resisted by many of the most important investigators in science of Lamarck's day. Principal among these, his opponents, was Georges Cuvier, the most powerful man in European science. He was veritably a giant of early 19th century science, a naturalist, a zoologist, a paleontologist, and he was a powerful opponent of transmutation. He resisted Lamarck at every single turn. Among his other claims to fame are that he founds vertebrate paleontology. It was said of Cuvier that he was so immensely perceptive that all he needed was a single bone from a fossil to be able to construct the skeleton, to be able to reconstruct what the animal would have looked like. But he was very much a believer that species were fixed and placed within a grid-like table, so there's no room for any form of speciation. He did, rather like many people at this time, recognise that there were similarities between species. For example, you could look at the wings of a bird or the flippers of a whale and see in them the limbs of a primate. But for Cuvier, this was because the form of the animal served a specific function. And from this, he mapped out the notion that there were 4 separate embranchements that animals could be organised into. And these were the vertebrata, animals that possessed a spinal cord, the articulata, arthropods and segmented worms, the mollusca, all other soft-bodied animals beyond the articulata, and the radiata, animals like jellyfish. And these categories were fixed. There was no way of bridging between the different categories. Cuvier, therefore, was absolutely opposed to Lamarck's ideas. We can see his opposition in the eloge that he gave for Lamarck in 1832 as his obituary for the great man after he had died. Among the men devoted to the noble employment of enlightening their fellows, a small number are to be found who gifted at the same time with a lofty imagination and a sound judgment, embracing in their vast conceptions the entire field of the sciences. The men that Cuvier was referring to at this point were pretty much himself, the great synthesizers, the objectivists. There were, however, other men. And these were the men like Lamarck, and you only have to read this quote to see the sarcasm, the facetiousness, the viciousness even of his view of Lamarck's ideas. Lamarck is nothing but a fantasist building enchanted palaces. It was a devastating attack. But in reality, Cuvier's real target was one of Lamarck's successors, an incredibly influential man, Etienne Geoffroy Saint-Hilaire, here satirized as an ape. Geoffroy was one of Lamarck's greatest allies, and he took his theory and developed it. Geoffroy wasn't a blind follower of Lamarck. In particular, he decided that the place where the impact of environment occurred was upon the embryo and its development within the body before birth. So Geoffroy's science demanded particular attention to embryology. So during the early part of the 1830s, there was a great debate between Geoffroy and Cuvier over the issue of the homology between different parts. So during the 1830s, in 1830, a great debate occurred between Cuvier and Geoffroy over the issue of the relationship between homologous and analogous parts of animals' anatomy. For Geoffroy, there was a homology between the external shell of a cuttlefish and the spine of a whale. The two not only had a similar function, one was descended from the other, and the similarity demonstrated descent through transmutation. Now, this idea was completely anathema to Cuvier. Remember those embranchements, 4 different categories, and they could not be bridged. What we see here is animals from 2 different categories, the mollusca and animals with vertebrae. Geoffroy was attacking Cuvier's embranchement and trying to demolish his system. Now, it has often been said that Cuvier was the winner of this debate. But when we look at what went on and the influence that Geoffroy continued to have over scientists, particularly radical scientists in places like Britain, we must realise that the debate settled nothing. And indeed, it was a debate that was only going to be settled for neither party once Darwin published his Origin of Species. Now, quite clearly, at the point where Charles Darwin's Origin of Species came out, his model of transmutation, or evolution as it became known, was radically different to that put forward by Lamarck and Geoffroy and all of those followers of that form of transmutationary thinking. By basing his theory upon Malthus, by exploring the way that speciation occurred through divergence and common descent, he was in a radically different zone. On that level, we must regard Darwin's theory as a revolution in evolutionary thinking at least. And equally, when we compare Darwin's new way of thinking with the dominant mode of thinking, in particular in relation to Cuvier's fixed ideas about the embranchement, when we look at that, evolution through natural selection looks radically different as well. In these terms, we observe the incommensurability that is at the heart of Kuhn's theory. And yet, when we look more deeply at the development of Darwin's theory during his own lifetime, but also at the way that his theory developed and became neo-Darwinism as we know it today, the idea that there was a revolution might appear to be slightly less convincing.